we are creating the 3D printouts. That is a part of, these are our students. These are our students. So what we have done, actually we have created a group of students for the project. We took it as a project and we started printing in the month of December. Generally we are starting the project work in the month of January, but as this was a slow process, because printing is a slow process, so that's why we have started this particular project in the month of December. And from December itself we have started printing the entire machine. So what we are doing is we are actually calling that particular component into one catalyst software. There is one catalyst software. This is a screen recording of my particular laptop. We are calling that particular component into this catalyst software. So you create the file. So I have called the component. Now I will ask the software to process this particular component. So it will break the component into several layers, thousands of layers. And then the printer will print those layers one by one. And you will get the 3D part. So this is the actual process, and it requires only 5 or 10 minutes, but for printing it requires a lot of hours. Suppose you give 2 or 3 components, so it may require 5 hours, 6 hours, like that. Then it will automatically orient that particular component. You can reduce the scale of the component, you can make it small or large depending upon your requirement. In this particular machine, actually we have scaled down the component to 1/4. 0.25 scale was taken. Then you can see that is the support material and the red one is the object material. So actually we started with this bucket elevator. So we started with this bucket elevator and we started the printing. So we actually sliced this bucket elevator into several components and then we started the printing. You can see some of the parts of the bucket elevator. When we joined those parts together, so in a period of 3 months, 3 महिने आम्ही printing केलं आणि फक्त bucket elevatorच तयार झालं. Because we were printing it on the weekdays, not on every day. So on the weekdays we were printing, probably on Saturday we were printing. So it was a very slow process. Itself, additive manufacturing is a very slow process. Even though it is called as a rapid prototyping, the process of 3D printing is quite slow. So in a span of 3 months, actually we were succeeded in printing the elevator only. The elevator was printed. Next. This is a video actually that I have shot with my mobile during the printing of the first component. So there is actually one glass shield. From the glass shield you can see the progress of the printing. There is one LED display also. And as I have said, it will actually deposit layers of the ABS material. Then there is a continuous deposition of the material and it will acquire the required height. And you can open that particular door also. If you want to insert something, you can open it. There is a deposition of layers, several layers. This is how the printing takes place. Actually it is laying down the support material. Now why the support material is required? Because sometimes the orientation of the object is such that you cannot deposit the material in the air. Suppose I want to print this particular thing like this. So here I have to give the support. If I place it like this, then there is no support required. If I place like this, then some support is required. So for the overhang portions actually support is required. It deposits the layer, support. First of all it will lay the support material, then it will start the object printing. And it will take a lot of time depending upon the size and complexity of the object. Then it will take some time for cooling also. then it will take some time for cleaning also, because we have to separate the support material from the object material. That is also required. So what we do is that we actually keep that particular printed part into the cleaning system for half an hour. There is a heating system and it will hit that particular part, and then they will get separated. Support material will get separated from the object. Next. Now you can see the finished part. Here you can see the finished part. And there is one display on the side of the 3D printer. It will show you how much time is required. Here you can see 64% is completed. Time remaining is 1 hour. 1 hour is left for entire printing to be finished. And then we assemble all the components together, and then we obtained some motors, belts from the tape recorder company, and we created the functional model. So this is the functional model. I am having only one video of this functional model. So here you can see we have created the entire functional. Same machine was printed with rapid prototyping that we have designed. The size of the machine is 1/4. We have printed it to the scale of 0.25. This is a functional machine, and we have used some DC motors from the tape recorder. And it will use all the motions. It is exactly replica of the original machine. We have printed all the parts, screens and all those parts, all the connecting rods, gears, motors, pulleys, everything, and frame also. Next. This is the actual photograph of the factory. So that is the first machine. This machine is the grade that we print. This is the actual photograph of the printed model with the RP. And as you can see, printed with 0.25 scale. So all the parts were printed with 0.25 scale, reduced damage. And this is the actually setup in the virtual environment. So we have created the virtual environment. We put the machines. We can give the motions to the machines, and we can create the virtual environment also. So we got the physical model as well as the virtual. In this video, you can see the virtual machine. Play the video. This is the virtual model, and that was a physical model. Actually, I have not described all the slides in length, because I want that you should ask some questions and some doubts will get clear in the question answer session. So actually I have completed the presentation in a super fast mode, because the technology is very simple. Just create a 3D print of the solid model. It is very simple to understand. So now you can ask the question, and I will try to answer this question to the best extent of my knowledge.
Sir, I have one question for you. What is the best printer scope for this?
Actually, RP is a very new technology. It was actually developed 20 years back in USA, and it came to India some 10 years back, and it came to Amravati some 5 years back. So right now we are using actually the rapid prototyping for the implants, bone implants. So our actually body is mirror image. So if I am having the accident, if I broke my bone, then I can create a similar type of bone from this bone, because my body is a mirror image. This bone and this bone is a mirror image. or this joint and this joint is a mirror image. So if I am having the accident and this bone is broken, I can create a similar type of perfect part from this bone. So what we do is that we go for the CT scan, we take the data, we create a solid model, we print it, then we send it to VNIT in Nagpur, then we create a implant, actually metallic implant, we coat it with phosphate, and then we give it to the surgeon, and surgeon is actually you are cutting your body and it is fixing that particular part. So this is actually expected from this machine. For that purpose, these machines were distributed to several locations in India. But as of now, we are only using 2% printed parts, and rest of the parts we are importing from one city in Germany that is called as Toulon city in Germany. So these are the ready-made parts, but our body is having a different signature. Every bone is different. My bone and your bone will be different. So you cannot fit a ready-made part into the bone. Just like say car, in car if something get damaged, we can replace that part with a similar type of part. But in bone it is not possible. So what we are doing is that we are importing a lot of bones. The surgeon is keeping boxes of those bones from 1 number to 100 number. Then he is operating the patient, he is cutting it. Then he is actually taking the measurement in the middle of the operation. Then he is finding whether box number 66 is matching or 67 is matching or 68 is matching, and it is not matching perfectly actually. So here actually we are creating a perfect customized part which is perfectly matching because it is taken from your bone. Because it is a replica. This bone and this bone, they are same. This bone and this bone is same. So if I got the fracture in this leg, I can create a replica of this particular bone from this bone. I can take a mirror image of that, and then I can actually create a customized implant which is perfectly matching, 100% matching, and there will not be any pain in the future.
So can we conclude that this technology is more suitable for medical field
No.
as compared to engineering field?
It is not for the medical field. Right now, our intention, our Prime Minister intention is that it should be used in the medical field because in America, 80% implants are created by rapid prototyping technique, whereas in India, only 2% implants are created by the RP machines. Because engineers and doctors, they are not working together. So we have got the technology, but doctor don't know. We are not going to the doctor and asking for any say assistance, or there are some hesitations for our assistance, because if we say to the doctor that I can create an implant, there will be a lot of questions whether it will fit or not. Then what is the credibility of that particular person? So a lot of questions are there because these things can be operated by engineers only, and doctor don't know that such type of technology is there. That's why in India only 2% implants are manufactured by the RP machine. Now what are the other uses of the RP machine? Actually we are using extensively for the rapid prototyping. Suppose we want to create a say car or mobile phone, and we want to launch that mobile phone or any product say within a short span of time. So we are not creating any kind of dies, we are not creating any kind of machine components, we are actually directly printing those components on the RP machine. We are assembling it and we are sending it to the expos. Suppose auto expo is there. I have designed a very small car, but there is only 8 days remaining. I have to launch the car within 8 days. So what I will do, I will print the entire parts of the car with the RP machine. So there are bigger size RP machines which can print the entire cars, and we can launch the car within 8 days.
Can we see the functional model what you showed there?
हाँ मागे गेलं ते आपलं मॉडेल होतं की नाही हाँ हे हेच
Second way. This one. Now you consider any pulley.
हाँ
What is the time required to complete by RP? Or any pulley you take?
any pulley, suppose you consider small size pulley,
Small size pulley.
so 2 hours or 3 hours are required
2 hours or 3 hours.
minimum. So we were printing actually 2 parts or 3 parts within a span of 5 hours. What we can do is that we can actually print several parts together. If there is a space on the plate, we can put several parts. And this machine can operate 24 hours, 24/7. It has got a auto shutdown mode. So you need not have to be there during the printing. You just start the printing and you go away. And next day you can come and you can take the part. It will automatically go into the shutdown mode. But in research center actually we were not doing like this because there is a chances of fire and there is chances of rats cutting the cables. So we were not keeping the machine unattended. म्हणजे आपण प्रिंटिंग दिलं आणि 24 तासानंतर 36 तासानंतर गेलो तरी चालतं, पण तिथे उंदीर असू शकतात किंवा स्पार्किंग होऊ शकतं, म्हणून आम्ही कधीही रात्रीचं प्रिंटिंग केलं. VNIT मध्ये आम्ही केलेलं आहे. In VNIT actually we were printing the parts and we were sleeping beside the machine, and in the morning we will be getting the components. So in the night actually I have started the component at VNIT and in the morning it was ready. Just
one last question, sir.
Yeah.
Now we are having the staff, nearly 70% staff are completed their post-graduation.
Yeah.
Now you are the supervisor and they want to continue your model or your technology. What type of suggestion you can give?
There is a lot of scope in actually RP research. So these models are not so smooth. There is actually staircase structure because they are printed layer by layer. So some research is going on for removing the staircase structure. Some research is going on for actually increasing the speed of the RP machine. Then increasing the fine or coarseness of the machine. So here actually we can lay a layer of 0.2 microns. We can reduce it to 0.15 microns, 0.1 micron, 0.5 microns, like that. There is a lot of scope in that.
Okay. Yes, anybody?
I hope you might have understood this point. समजलं असेल, म्हणजे जरी प्रेझेंटेशन फार टेक्निकल होतं तरी समजलं असेल. आणि काही विचारायचं आहे का तुम्हाला?
सर, व्हॉट इज द कॉस्ट ऑफ दॅट ग्रेडर वरदान?
ग्रेडर मशीन ॲक्च्युली जी ग्रेडर मशीन आहे जी तुम्ही पाहताय ॲक्च्युली ती आम्ही कॉपी केलेली आहे 20 वर्षापूर्वी. आम्ही काय करायचो की जर्मनी किंवा इंग्लंड किंवा अमेरिकेतले जे एक्झिबिशन्स राहायचे ॲग्रो मशीन्स, ॲग्रो मशीनच्या एक्झिबिशन्समध्ये जायचं, तिथे फोटो काढायचे. कधी कधी मशीन्स घेऊन यायचं, म्हणजे इम्पोर्ट करून द्यायचं. इम्पोर्ट केल्याच्या नंतर त्याला ओपन करायचं. जसं चायना आजकाल करते. चायना काय करते, कोणतेही प्रॉडक्ट घेतलं की त्याला ओपन करते, मग ते पूर्ण सर्च आणि मग त्याचं मॉडेल तयार करायचं. आणि मॉडेल तयार करून मग तीच मशीन 1/10 कॉस्टमध्ये आपण बनवायचं. समजा 4 लाखाची मशीन असेल, आमचं ऑब्जेक्टिव्ह राहायचं की 40,000 ती मशीन बनवली पाहिजे. ह्या मशीन्स मी 20 वर्षा अगोदर कॉपी केलेल्या मशीन्स आहेत, ज्या युरोपियन मशीन्सच्या कॉपीज आहेत. म्हणजे इनिशियली दे हॅव डेव्हलप दिस मशीन्स. आपण काय केलं, त्याला कॉपी केली. आपण आपल्या इकडचं मटेरियल वापरलं, आपण डिझाईनवर कोणताच खर्च केला नाही, आपण सरळ कॉपी केलं, मेजरमेंट केलं आणि त्याला कॉपी केलं, त्याचं मॉडेल बनवलं. आणि मग आपले जे लोक आहेत त्यांनी त्या मशीन्स पुन्हा तयार केल्या. आता जेव्हा आपण कॉपी करतो तेव्हा 100% आपण कॉपी नाही करू शकत, कारण काही ना काही एरर आहे. आमच्या ज्या पहिल्या ज्या मशीन्स होत्या त्या एकदम खराब होत्या, म्हणजे ते इतक्या खराब होत्या की इतके आवाज करायच्या आणि कधी कधी एवढे व्हायब्रेशन्स व्हायचे की ते फाउंडेशन तोडून बाहेर पडून जायचे, एवढे व्हायब्रेशन्स व्हायचे. मग पहिला शेतकऱ्याला आपण ती दिली तर मग तो खूप हे करायचा की काय जे कंपोनंट्स तुटतात, त्याचे बेल्ट तुटतात किंवा ते फिरत नाही किंवा हे. मग ते दुसऱ्या वर्षी त्याला थोडंसं मॉडिफाय करायचं, तिसऱ्या वर्षी मॉडिफाय करायचं, असं मॉडिफाय करता 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 ते आपण मॉडिफाय केलं. आणि ही जी मशीन आहे तुम्ही जी पाहताय, ही जी दाखवलेली आहे ही मशीन, हे ॲक्च्युअलमध्ये याचं छोटं व्हर्जन तयार केलं. तर ती मशीन जी आहे खूप मोठी होती. आपण आता काय करतो ते बचत गटांना विकतो. बचत गटांचं जे बजेट असते ते 5 लाखात असते. आता हा जर सेटअप लावायचा असेल 25 लाखाचा असेल, 25 लाख ते शेतकरी खर्च नाही करू शकतो. मग आता शेतकरी 5 लाखाचं बजेट आहे, 5 लाखात आपल्याला 3 मशीन्स बसवायचे आहेत. त्या 3 मशीन्स काय करायचं 5 लाखात बसवत आहे. आपण काय केलं, त्याला छोटं केलं. आता जी तुम्ही पाहिली आहे ते त्याचं मिनिचराइज व्हर्जन आहे, छोटं व्हर्जन, स्मॉल व्हर्जन. ॲक्च्युअल मशीन पडगिलवारमध्ये जी मोठी आहे त्याच्यामध्ये म्हणजे एक पोतं टाकलं तर 10 मिनिटातच क्लिनिंग करतं. आपल्या इथं एक पोतं 1 घंटा लागतं समजा क्लिनिंग. आपण छोटी मशीन केली आणि ती बचत गटाच्या हिशोबाने केली की बा 4-5 शेतकरी येतील, नंतर ते पैसे जमा करतील, मग ते आपल्या शेतामध्ये ती मशीन लावतील, आपल्याला अप्रोच करतील, आपण त्यांना सबसिडी देऊ आणि ते सेल करू. कारण की शेतकरी काय करतात, शेतकरी ते आळशी असतात, ते माल घेऊन जावं पैसे देऊन ते क्लिनिंग नाही करत. मग हे मॉलवाले काय करतात, शेतकऱ्यांचा माल घेतात, त्याला क्लिनिंग करतात, क्लिनिंग करून त्याचा भाव एकदम वाढून जातो आणि सर्व प्रॉफिट जो आहे तो मॉलवाल्यांना होतो. आणि डीमार्ट असेल तर डीमार्टवाला काय करतो, शेतकऱ्यांकडून गहू घेऊन घेतो, गहू म्हणा, सोयाबीन म्हणा, कोणतंही ग्रेन म्हणा, त्याला क्लिनिंग करून तो त्याचा व्हॅल्यू ॲडिशन दुप्पट करून टाकतो आहे. म्हणजे समजा 10 रुपये किलो असेल तर त्याचं 20 रुपये किलो जाते क्लिनिंग झाल्यावर. जस्ट त्या 3 मशीनमधून तर पास करतो. एक आहे आपली ग्रेडर, त्याच्यामध्ये आपण साईजनी ग्रेडिंग करतो. दुसरं आहे ग्रॅव्हिटी सेपरेटर, ते आपलं सूप असते ना, सूप ते सुपासारखं असतं, त्याने ग्रॅव्हिटीनी सेपरेशन होतं. आणि थर्ड असते डिस्टोनर. डिस्टोनर म्हणजे खडे बाजूला काढणं. ते तिसरी मशीन जी आहे ते फक्त खडे काढून टाकते. एक वेळा 3 मशीनमधून तुम्ही धान्य पास केलं की ते एकदम क्लीन होऊन जाते आणि त्याचा भाव एकदम वाढून जातो. जो फायदा शेतकऱ्याला व्हायला पाहिजे तो ॲक्च्युअलमध्ये मॉलवाल्यांना होतो. कारण की ते त्याचं ब्रँडिंग करतात, ते त्यांचं स्टिकर लावतात आणि तो मॉलवाल्यांना फायदा होतो. आपला ऑब्जेक्टिव्ह किंवा सरकारचा ऑब्जेक्टिव्ह काय आहे की बचत गटांनी एकत्र यावं, ह्या मशीन्स त्यांनी खरेदी कराव्या, त्यांच्या शेतात लावाव्या आणि त्यांनी स्वतः क्लिनिंग करावं, त्याचं पॅकेजिंग करावं आणि फिनिश प्रोडक्ट तिकडे विकावं. म्हणजे जो प्रॉफिट तिकडे चालला आहे तो शेतकऱ्यांना मिळावा. आता शेतकरी 5 लाख जमा करायचे म्हटले, समजा 50-50 हजाराचं कॉन्ट्रिब्युशन असेल तर 10 शेतकरी झाले. 10 शेतकरी एकत्र येत नाहीत लोक, त्यांच्यात भांडणं असतात, कसं ऑपरेट करायचं, काय ऑपरेट करायचं, शेतात लावायचं आहे, आपल्याला खूप मोठं जागा नाही पाहिजे, म्हणजे छोटं करावं लागेल म्हणून आपण ते छोट्या केलेल्या. ह्या कॉपीज आहेत ॲक्च्युअली, आपण फॉरेनच्या मशीनच्या सरळ सरळ कॉपीज केल्या. ओके. आणि रिव्हर्स इंजिनिअरिंगनी मला तयार इन इंडिया. आणि आपले जे आता कारागीर आहेत ते 200 रुपये 300 रुपये रोजाने ते पूर्ण मशीन्स करतात. म्हणजे 10 दिवस लागले तरी आपल्याला फार कॉस्टिंग येत नाही. हा सेटअप जो आहे तो 5 लाखाचा, 3 मशीनचा सेटअप 5 लाखाचा. त्याच्यामध्ये 50-50 हजाराचे बकेट लिमिटेड आहे, 3 मशीन्स वेगवेगळ्या कॉस्ट. बऱ्याच ठिकाणी दिलेले आहेत मशीन्स, बऱ्याच ठिकाणी दिले. हां, आपण इथे प्रोटोटाइप करतोय ना, प्रतिकृती तयार करतो. प्रोटोटाइप मीन्स व्हॉट, रिप्लिका ऑफ दी ओरिजिनल मशीन. आपल्याला अंडरस्टँडिंगसाठी आता मशीन आपण इथं आणू नाही शकतो, तुम्ही मॉडेल आणू शकतो आणि विद्यार्थ्यांना दाखवायचा मॉडेल मी उचलून आणू शकतो. यू कॅनॉट टेक दी एंटायर मशीन. कारण मशीन जर तुम्हाला दाखवायचं असेल तर त्याला तुम्हाला फाउंडेशन करावं लागेल, त्याला इलेक्ट्रिसिटी सप्लाय लागेल, 3 फेज पॉवर सप्लाय लागेल. सो मॉडेल कॅन बी ॲक्च्युअली ट्रान्सपोर्टेड टू एनी लोकेशन, बट यू कॅनॉट टेक द डायरेक्ट मशीन. आपण डायरेक्ट मशीन जर काय पाहायचं असेल तर काय करावं लागेल, आपल्याला तिथे जावं लागेल, म्हणजे त्या लोकेशनला जावं. डायरेक्ट मशीनचं जर कामकाज पाहायचं असेल तर आपल्याला तिथे जावं. आम्ही 2-3 वर्षाअगोदर मी, घुमटे सर आणि माझे 2 मित्र आहेत, आम्ही गेलो होतो भंडारा रोडवर गेलो, नागपूरला गेलो पहिले, तिथून भंडारा रोडला गेलो आणि ते जवळपास 12-13 किलोमीटर होतं त्या भंडारा रोडवर. तिथे ते ॲक्च्युअल मशीन्स लावलेले होते, ते तिथे मशीन्स होत्या आणि त्या कॉल केला म्हणजे आम्ही तिथे जवळ पोहोचलो तरी आम्हाला समजलं नाही की बाजूलाच आहे. म्हणजे त्यांनी सांगितलं तुम दिख रहे बोले मेरे को, अब आ जाओ बोले खेत के अंदर आहे बोला आम्हाला. आणि मग आम्ही तिथे गेलो. हे एबीएस मटेरियलमध्ये आपण केलेलं आहे. ॲक्रोब्युटिनिल स्टेरेन नावाचं मटेरियल आहे. इट इज वन काइंड ऑफ प्लास्टिक. ॲक्च्युअली इट इज नॉट अ प्लास्टिक, इट इज अ लो मेल्टिंग मटेरियल. इट melts and solidifies very quickly.
What are the uses for civil, electrical and electronic?
For actually in electrical, we can print electrical machines. We can create prototypes of electrical machines. For civil engineers, actually we are not using this machine. There are separate machines for civil engineers and architects. Suppose you have created a bridge and you want to create a prototype of that bridge, or you have created a say skyscraper. So for that we are using low accuracy machines. These are the high accuracy machines. These are the closed machines. We are using the open machines for civil engineers and architects. Because their accuracy is not required. For the prototype, accuracy is not required. So this is the high accuracy machine. For civil engineers, we are using low accurate machines. The cost of the machine is quite less. You can get those machines within 50,000 or 1 lakh. So many of the architects are actually using those machines and they are creating the prototype of entire their plant. Say suppose they have planned some city, then they can print the entire city and they can show to the probable customer that the city will be like this, swimming pool will be like this, the shopping mall will be like this. So they are creating the models. For that purpose they are using. Or if you are creating say some bridge, then you can print the model of the bridge.
3D house printing. 3D house printing.
House printing also. Anything you can print. Anything you can.
previously actually they building a 3D house printing.
हाँ. सिविल इंजिनियर वापरतात आपले